are you? I hope you will be enjoying your day, guys. So, welcome to Let's Crack JEE English channel, guys. And this is the India's biggest platform, that is Unacademy. Guys, let me check my voice. Just a second. Just a second. Okay. Okay. So, yeah. So, is my voice clear? Okay. So, yeah. Is my voice clear? Yes, my voice is very my voice is very clear, guys. Yeah, so what I was saying, you must be enjoying your day, guys, and today is our, like, I think fourth lecture of mole concept, and in this lecture we gonna study the different laws of chemical combination that we will study, and we will do lots of question for that. And yeah, I will give you some homework also, so please try those, and we will discuss the answers in the next class. Okay, so welcome to Let's Crack JEE channel, guys, and this is the India's biggest platform, that is Unacademy. So this is me, guys. My name is Komal Jain, and I have done masters in chemistry from IIT Guwahati. I have done masters in chemistry from IIT Guwahati, and I have done BSc honors chemistry from Gargi College, Delhi University. I was second topper of Gargi College, as well as I was one of the topper of IIT Guwahati. Guys, I have cleared so many national level entrance exams, just like I have cleared lecturership, that is CSR net lecturership exam with 31 all over India rank, and I have cleared like JRF, that is Junior Research Fellowship exam with 76 all over India rank. IIT GEM, I cleared that exam with 165 all over India rank. So you can say that I have cleared so many exams. So if I can, you can, guys. So remember that miracle is nothing but it is the another name of hard effort that you do in your daily life, guys. Daily. So guys, you and me come close to each other because of this, YouTube channel. But this YouTube channel has lots of demerits, because here you can't send your doubts, you can't give a proper test, you cannot you know uh, exceed your timings, or you cannot match with the timings, because there is some lag that exists in YouTube. Whenever we come live, so there is a lag, like whatever I'm saying here, and that comes to you after 30 seconds. So there is 30 seconds or 1 minute lag over there. But in the Unacademy, on the Unacademy platform, on the Unacademy learning app, there is no lag. So you will be you will experience real time interaction there. Okay, so what you can do, you just have to do one thing only, that you have to install the Unacademy learning app from the Play Store. Okay, and when you install this Unacademy learning app, then you will be exploring that app, and you will see that there are two options, that is special class and the plus classes. What is the special class and what is the plus class, guys? Special class is free of cost. Okay, so you can watch without paying any single penny. And how these special class help you, guys? See, you want to take, or you want to take an admission in a course or in a batch. Okay, but you don't know about the educator, you don't know how the educator teach, what is the style. So you can go to the special class of his or her. Okay, then you can attend that class, and you will get an idea ki no, that's how he teach, or that's how she teach. So by looking over that, you can easily get an idea in your mind that whether you want to take this plus subscription or not. Okay, now if you take this plus subscription, then there are also many benefits that you get on this platform. First is daily live classes. There are live classes from Monday to Sunday, means there are 7 days in a week, or the classes will held 7 days in a week. Okay, so every day you have a class, or you have a class of each and every subject, that is physics, chemistry, math, all subjects has a class on each day. Okay, so yeah. Next is live tests and quizzes. So whenever we teach a content, whenever we teach you something, then we will take your test, we will take your quiz there. And there are structured courses, like whenever you attend a course, you join a batch, you join a course, then every fourth session is a doubt session, guys. So your doubt will automatically clear in the doubt clearing session. Okay, and next is unlimited access. Guys, this is not something that you gonna take the subscription and you will get an access to only a batch or only the class for an educator. You get the access for whole, like for whole plus classes, like whatever the course it is, you can take and join that class. Okay, you can go and attend the class of any educator of your choice. So you actually choose your educator, guys, and this is not happen in offline classes. Okay, next is iconic subscription. In iconic subscription, you get the personal coach, you get proper test analysis, you get study planner, and you get all benefits of plus. So iconic is something, extra as compared to your plus, because plus is just like a offline batch. The other, but the main benefits of plus is you get 7 days in a week class, and you get class of you can get class of any educator, you can choose your educator. But iconic is something advanced. You get plus personal coach, study planner, test analysis. So if you want, if you want to take plus subscription, then you can get these four benefits. And if you want to take 1 year subscription, guys, remember that corona cases are increasing day by day, so there is a chances that further lockdown will happen. And if that happened, then your studies will get affected, guys. Okay, so remember to take a subscription which will help you even when the lockdown happened again. Okay, so take the subscription and invest less money, that I will suggest you. Or if you go over there, then you will find that Unacademy has so many benefits, and you have to pay not much. Not much you have to pay, you have to pay very less. Because if you see 1 year classes, then you have to pay only 38,500 rupees. 1 year 38,500, and then you also get a 10% discount when you use my code KJEN code. You use that code and you will get 10% discount, and you get same thing in 34,650, guys. So there is a benefit that you get 1 year course in just 38,500. Again, you will get a 10% discount also there. Okay, if you want to take 2 year subscription, guys, because if you think that offline courses are better than online courses, then let me tell you, guys, the educator whoever were teaching offline is now online, and they are present on Unacademy. So why you are going to other places, why you are paying more, or even you are investing your money in traveling also? So guys, don't do that, because this is corona time, and corona time needs a digital system in your studies. So if you want to take 2 year subscription, then you can take it in 56,000. But yes, with my code you will get 10% discount, guys, and you will get the same thing in 50,400. Okay, so if I talk about the iconic, guys, you get all the benefits in iconic. You will get 1 year. For 1 year subscription, you have to pay 56,000, and when you use my code, that is KJEN code, you will get 10% discount, and you will get the same thing in 50,400. Okay, let's suppose that you want to take 2 year subscription, you want to take 24 month subscription, guys, then you have to pay 86,000, and you get same thing in 77,400 when you use my code, that is KJEN code, for getting 10% discount. Now you can imagine, guys, that You are getting benefits, you are getting discount, you are getting a full course, a 1 year or 2 year full course in very cheap amount as compared to the offline batches, or as compared to the other online sites. So this is what Unacademy is, guys. So I want to tell you about my schedule, guys. Okay, there is some, like, I haven't changed this because this has changed. Okay, let me tell you guys, there is something new here. Special class, please cut this down, guys. Please cut this down. Okay, this is cut it, and there is daily, we will get a special class at 9:30 a.m. where we are solving MS1 book and topic of your choice. Okay, like if you want to understand any topic of your choice, then you can message me, and on 9:30 a.m. we will arrange that class for you. On plus, I am teaching a capsule course or for the organic chemistry, for all reactions of organic chemistry, at 7 p.m. on Monday, Wednesday and Friday. YouTube, I am teaching on 2 channels, Let's Crack JEE and Let's Crack JEE English channel. Let's Crack JEE English channel, you already know that we are covering full chemistry course, and Let's Crack JEE channel, we're gonna start the full organic chemistry track, guys, from tomorrow. From tomorrow we will start this thing, and the class will held at 9 p.m. Okay, Saturday will be something special for you. So I haven't mentioned any channel here or any time here because I don't know on Saturday I will be free on what time. But you have to, like, subscribe those channels, guys, so that you can attend my each and every session. So we have completed these many classes in my plus course. I have completed these 5 classes. Now I have, like, in the further plus classes, I will complete these topics also. Okay, so let's move on to this part 4. Yeah, I think this is part 4 or part 3. I don't know. I don't remember that, guys. Okay, so we're gonna do the laws of chemical combination in today's class. Now, what are the laws of chemical combination? What are the different laws of chemical combination? We have different laws, like we have laws of conservation of mass, we have law of definite proportion, we have law of multiple proportion, we have law of, reciprocal proportion, we have a law of Gay-Lussac law of volume, we have a Avogadro hypothesis. So these many things we will study one by one with the statement, limitation, example and question. Okay, so these 4 things we will study for each and every law. So let's start with the first one, that is the law of conservation of mass. Okay, so let's study the first law, that is the law of conservation of mass. Now, as this law is, saying you that mass conservation of mass, that there is a conservation of mass, that means mass will remain conserved, it will not destroyed or formed. Okay, it will remain constant. Whatever mass you are taking, that will remain constant during the course of your reaction. Like whatever the mass of reactant you have taken, the same mass of the product will be formed if your reactant is 100% complete. Okay, now this I have written here, like the law of conservation of mass. Hi Siddharth, good evening bacha, good evening. So this law of conservation of mass is actually given by Antony Lavoisier in 1789. Now you can imagine how many years back this law has given, guys. Okay, so what this laws tell you, in any physical or chemical change, mass can neither be created nor be destroyed. Okay, that means mass remain conserved, it will not change, it will remain constant, because it is not changing, it is not creating, and it is not destroying, so it will remain constant, right, during a chemical change or a physical change. Okay, physical change is what? For example, you are boiling the water, this is nothing but a physical change. So if you like boiling your water and you are converting this into the water vapor, and then you check the mass of this water, okay, and mass of this water vapor. If you check the mass of both, then you will find that both have same masses, both have same mass. So we can say that mass is remain conserved. Okay. Similarly, during a course of a reaction, for example, if A is reacting with a B and they are reacting together and forming a C, okay, then the mass of this A plus B will be same as the mass of C, or mass of reactant will be equal to the mass of product, only if the reaction is 100% complete. Okay, that is, there is no reactant left in this reaction, then we can say whatever the mass we have taken of reactant, the same mass will be formed of the product. Okay, now I have different points for that also. Total mass will remain conserved. Mass before the reaction is always equal to the mass after the reaction. So we can say total mass of the reactant will be equal to total mass of product. Okay, next thing, note, there is a note also. The relationship holds good when reactant are completely converted into the product. That means ki reaction is 100% complete. Only then you can use this formula, guys. Okay. If the, let's say if the reaction is not completed, if the reaction is not completed, okay, so there are reactants, there are some products. Okay, if the reaction is not 100% completed, then there are reactant which will remain unreacted, which will not form product. Okay, so we can say the mass of the reactant, and in that case total mass of the reactant will be equals to total mass of product plus the total mass of unreacted reactant. Okay, so whatever the mass of the reactant you have taken will be equals to the mass of the product that is formed plus the mass of the unreacted reactant, that means those reactant which hasn't formed the product. Okay, so this is actually the law of conservation of mass. So there is also an example that I have written here, guys. This is an example, like for example, I have A, I have B. These two are reactant, they are reacting together and they are forming C and D. At T is equals to 0, that means time is 0. That means the reaction hasn't started, guys. The reaction has not started. At that time there will be no product because reaction is not done. I have just taken the reactant. Okay, reaction is not started, no. Okay, so we have some mass of A, some mass of B, that is represented by WA and WB. Okay, now let's say I have taken the time where the reaction is completed. I have taken the time when the reaction is completed. Let's suppose 10 minutes, 20 minutes is the time where when the reaction is completed. Okay, when the reaction will complete, the reactant will become 0. Okay, that will completely disappear and they will form product. And we have some mass of C, we have some mass of D, that is represented by WC and WD. So I can write here that during this course of reaction, my mass of reactant will be equals to mass of product. Okay, then I can say that law of conservation is followed. Okay, and in the another sense, or in other words, I can also write this conservation of mass as number of atoms of an element in the reactant will be equal to the number of atoms of that element in the product. For example, guys, I have hydrogen, I have oxygen, I am reacting these two together and I am forming water here. Now you can balance this reaction. Now this is a balanced reaction. Now check out, guys. Check out. This has a mass of 4 gram because hydrogen has a molecular weight of 1 gram. And we have 2 hydrogen, so it will be 2 gram, and 2 multiplied by 2, that will be 4 grams. Okay, oxygen, one oxygen atom has 16 gram weight, or 1 mole of oxygen has a 16 gram weight. So we have 2 oxygen here, so I will be having 32 gram, or you can say 16 multiplied by 2, that will be 32 grams. Now calculate the mass of this water. Okay, now for water I have to multiply 2 with the mass of hydrogen, that is 1, plus the mass of oxygen, that is 16, and again I have to multiply this mass of water with the 2. So what I will be getting? I will be getting 36. Okay, similarly here also I am getting 36. So I can say guys, the mass is remained same. Mass hasn't changed. Okay, mass is remained same during this reaction. Also, I can say from this reaction that number of atoms is also conserved. We have 4 atom for hydrogen, 2 and 2. 2 multiplied by 2, that is 4. So we have 4 hydrogen atom in the reactant. Similarly, in the product we have also 4. 2 into 2, that is 4. So we have 4 atoms of hydrogen. So atoms remain conserved or mass remain conserved, both are same thing, but we have defined in the in the terms of mass. So that is why we have given this law as name. We have named this law as law of conservation of mass. Now you are getting everything, guys. Okay, now let's do this question, guys. Now this is a question, this is a very good question that we will that will explain you everything, guys. This question is stating that we have, yeah, you have 1.7 grams of silver nitrate dissolved in 100 grams of water. Okay, you have taken 100 gram of water and in that you have added 1.7 gram of silver nitrate. Okay, also you have taken 0.585 gram of sodium chloride dissolved in 100 gram of water is added to it. So I am representing whole things here. So we have silver nitrate, that is equals to 1.7 grams, and we have water, that is 100 gram. 100 gram. Okay, that we have taken. Okay, and in the next thing that we have taken 0.585 gram of NaCl, that is sodium chloride, and 100 gram of water. 100 gram of water. Okay, now we have mixed these two things. We have mixed these two things and the reaction is happening such that in product we have 1.435, see this, 1.435 gram of AgCl and 0.85 gram of NaNO3. Now write this over here, guys. 1.435 gram of AgCl and 0.85 gram of NaNO3. Okay, now this question is asking you check that these results match with the law of conservation or not, or this question is following law of conservation of mass or not. So let's do this question, guys. Okay, we know from the law of conservation of mass, total mass of reactant should be equals to total mass of product. Okay, that we know from the conservation of mass. Okay, so that you are not giving me the answer today. Why? So let's check it out first. The total mass of reactant. Now in reactant, what we have, guys, we have silver nitrate, we have NaCl, and we have water. Okay, now let's add the mass of all these three things. That will be silver nitrate mass plus NaCl plus water. Add all the things, guys. Silver nitrate we have 1.7 gram, NaCl we have 0.585 grams, and water we have 200 gram. 100 here and 100 here, so that will make 200. So 200 here. No, that will not be 2.285. That will be 202.285. I think you have missed missed something in writing. 202.285 grams. So the mass of reactant will be this thing. Okay, have you understood this thing? Okay, guys, if it is saying that in the product we have AgCl, we have NaNO3, then the reaction is actually happened in between the AgNO3 and the NaCl. Check it out. silver nitrate, if it is reacted with the NaCl, then we will be having AgCl and NaNO3. Okay, so we can say that water hasn't take part in the chemical reaction. So we have a water here and the same mass of the water, that is 200 grams. Now check out the mass of product. What is the mass of product, guys? Mass of product. So for this I have to add like mass of AgCl, NaNO3 and water. Now what is the mass? AgCl we have 1.435, 1.435, NaNO3 that we having 0.85, 0.85, and water we having 200 grams. Check guys ki if it is matching with the 202.285 value or not. Okay, you are excluding water. Okay, I got it. Tell me what will be this thing. If you calculate this thing, you will also get 202.285 grams. Now you can easily say that before the reaction we have a mass of this, after the reaction also we have the same mass. So we can say guys, mass is conserved. Okay, mass is conserved. So we can say law of conservation of mass is followed. Law of conservation of mass is followed. That's actually a very easy question. Now I am giving you a question for the homework, guys. Please do this question and we will discuss the answer of this question in the next class. So you can take the screenshot and you can solve this question. Okay, you can take the screenshot, you can solve this question. I will ask you the answer in the next class. Okay, so let's move on to the limitation. One thing in the law of conservation of mass. Okay, one limitation is there in the law of conservation of mass. That is, law of conservation of mass is actually applicable for the normal chemical reaction, because in normal chemical reaction there is there is no mass is created, no mass is destroyed. But if I talk about nuclear reactions, then we know that some of the element is actually making more different elements. For example, uranium is actually radioactive, so it participates in the nuclear reaction. It forms many different elements by the emission of the beta particles, alpha particles, rays, energies. So in the nuclear reaction some mass is lost in the form of energy. So if some mass is lost, then law of conservation of mass will be not followed in the nuclear reaction, and that is the biggest limitation of law of conservation of mass. Okay, next let's talk about the law of definite proportion. Definite means fixed. Proportion is nothing but a kind of ratio or kind of mass that is fixed. Let us understand this thing in detail. Law of definite proportion is actually given by Joseph Proust, who was a French chemist. The year is actually not mentioned in your book, so I haven't written over here. Okay. Now what this law states. It states that a given compound always contains exactly the same proportion of the element by weight. Means if you are taking water, let's suppose if you are taking water from a pond, then the formula of the water will be H2. Okay. If you are synthesizing water in the laboratory, then the formula of the water will be same, that will be H2. And if you like taking water from your washroom, then also the formula will remain same, that is nothing but H2. So what we can say in water the formula remains same. If the formula remains same, then we can say ki uh, we have definite proportion of the different element. We have two hydrogen over here, we have one oxygen over here. If we have two hydrogen and one oxygen over there always in the formula of the water, then we can say we have 2 gram of hydrogen and we have 16 gram of hydrogen, sorry, 16 gram of oxygen always, that combine to form the water molecule. So here we have a fixed proportion of the element by weight. You can also check it out by the ratio. For example, if you are checking the ratio of the mass of hydrogen and oxygen in the water molecule, then hydrogen has 2 gram and oxygen has 16 gram. Take the ratio, you will get 1:8. So hydrogen and oxygen combine in 1:8 weight ratio to form water. Okay? Yeah. So that I have written. A pure chemical compound always contains the same elements combined together in the fixed ratio of their weight. Okay. So whenever a pure compound is formed, then the element, that is hydrogen and oxygen or any element, combined in a fixed ratio of their weight. Here it is 2:16 or 1:8. Okay. And the method will not depend upon the preparation of the preparation or the source from which it is obtained. So from whatever source you take out your water, you take water from your from your river, from your pond, or you synthesize even water in the laboratory, the formula of the water will always remain the same. If the formula remains same, then the number of hydrogen and number of oxygen is fixed. If the number of atom of oxygen and hydrogen both are fixed, then the mass of them are fixed. If the mass of them are fixed, then the ratio are fixed, and this is nothing but called the law of definite proportion. Similarly, I have given an example of CO2 over here. In CO2, you can imagine we have one carbon atom, we have two oxygen atom. That means we have 12 gram of carbon, we have 2 into 16, that is 32 grams of oxygen. If I take the ratio, then I will get 3 over here and 8 over here. Okay, so we can say that carbon and oxygen combines in the ratio of 3:8 to form CO2. Okay, I think you have understood everything. Now let's do this question, guys. Now what this is saying here, you have 1.08 gram of copper wire was allowed to react with nitric acid. You have a copper here, that is 1.08 grams, and you are reacting this with the HNO3, that is nitric acid. Okay, the resulting solution is dried and ignited. Okay, okay, so let me just do this thing, guys. When the copper react with HNO3, then it form the copper nitrate. I'm not writing the full reaction over here, I'm just writing what will be the product expected, a kind of product. So copper nitrate will be formed. Now it is saying that we have ignited and we are getting 1.35 gram of copper oxide. So we are heating this and we are getting copper oxide 1.35 grams. Okay. Now this was first experiment. Now you are giving with the second experiment also. In the second experiment, we have 2.3 gram of copper oxide heated in the presence of hydrogen. 2.3 gram of copper oxide heating in the presence of hydrogen to yield 1.84 gram of copper. Show that above data is in accordance with the law of constant composition. Now you have to check that law of constant composition or law of definite proportion is valid or not for this case. Now how will you check, guys? How will you check? See, if you want to like check out that whether the law of constant composition is valid or not, then you have to calculate how many how many you or how much copper is present in this copper oxide. Okay, and that will be nothing but 1.08 gram. Okay, in this copper oxide 1.08 gram of the copper will be present. Okay, so we will be writing this thing over here. So in the copper oxide, when we have 1.35 gram of copper oxide, then the copper was 1.08 gram. Okay, in the next experiment we have copper oxide 2.3 gram and copper 1.84 grams. So we have copper oxide 2.3 grams, 2.3 grams, and we have a copper, how much? It is 1.84 grams. Okay, we have a copper 1.84 grams. Now I want to check whether my law of conservation is valid or not. Law of constant composition is valid or not. So for this, what I need to do, I have to fix the amount of one thing, or I have to make the amount of one thing same. Like we for first experiment, for second experiment, we have different values for copper oxide and copper. Here it is 1.35, here it is 1.08, here it is 2.3, here it is 1.84. Now I want to make this value and this value same. So how will I do this thing? See, for 1.35 gram, I have only 1.08 gram of copper. So for 1 gram, we will be having 1 gram, we will be having 1.08 divided by 1.35 gram of copper. Okay, so if I have 1 gram of copper oxide, then I will be having this gram of copper. Similarly, from this I can say we have 2.3 gram of copper oxide. For this 2.3 gram of copper oxide, we have 1.84 gram of copper, right? So for 1 gram of copper oxide, we have 1.84 divided by 2.3 gram of copper. Now check out, guys, I have actually fixed 1 gram here. I'm actually fixed copper oxide mass as 1 gram. Okay, and now I'm calculating this, the mass of copper only. Now calculate the mass and you will get your value, guys. Here, what will you get? Tell me. You will get 0.8. Okay, here also you will get 0.8. Okay, yeah, so solve this and you will get 0.8. Now see, for the same amount of copper oxide, we have same amount of copper. I can say that, no? For 1 gram of copper oxide in the first experiment, we have 0.8 gram of copper. Similarly, in the second experiment, for 1 gram of copper oxide, we have 0.8 gram of copper. So the mass is fixed. Mass is fixed for both. So I can say law of definite proportion is valid. Proportion is valid. Is valid. Okay. Now this you have, I'm giving you as a homework. Please solve this question and we will discuss the answer in the next class. Till then you can take the screenshot of this question. Okay. Okay, so let's move on to the next, that is limitation. Guys, this law actually tell you that whenever a compound is formed, then the mass is fixed. But what happened what will happen actually if the mass of the element is not fixed? I know that for the carbon I have two isotopes. I have carbon, I have, three isotopes. We have carbon 12 isotope, we have carbon 13 isotope, we have carbon 14 isotope. So if I have a CO2, but we have, like, for example, we have two molecules of CO2 in which one carbon is carbon 12 and another carbon is carbon 14. Now what will you comment over this, guys? Will the mass will be fixed or not? The mass will not be fixed, guys, because here the combination is like carbon is actually 12 gram and oxygen is actually 32 grams, which is combining to form this carbon 12 CO2. Okay, carbon will be 12 gram and oxygen will be 32 grams, and that creates a ratio of 3:8. So from here, what will I predict? That carbon and oxygen always combine in the form of 3:8 to form CO2. Okay, but that is not the case with the carbon 14. If there is an isotope of carbon, okay, then the ratio will change. Here the ratio will be 7:16. Now what will you comment over this? The carbon and oxygen will combine in the ratio of 7:16 to form the CO2. No, this ratio is changing, guys. That means this is not following the law of definite proportion. Okay, so we can say in case of isotope the ratio is not fixed, ratio will change. Okay, the ratio will change. Next, let's talk about the law of multiple proportion. Now what this law state, or who has given this law? Dalton in 1803 has given this law. According to this law, if two elements can combine to form more than one compound, then mass of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers. Let us understand this thing with the help of an example. Okay. Suppose we have hydrogen and oxygen as the reactant. Okay. Now hydrogen and oxygen can react together to form, more than one type of compound. It can form water, it can form hydrogen peroxide. In both the compound, what is happening? The ratio is changing in which hydrogen and oxygen reacting. Okay. For example, in H2, let's suppose we have 36 gram of water. We have 36 gram of water. For this, we should have 32 gram of oxygen and 4 gram of hydrogen. Okay. If I take the simplest ratio, then I will get 2 gram, 16 gram and 18 gram. Similarly, for hydrogen peroxide, I am getting 2 gram, 32 gram and 34 grams. Now see, let's suppose that I am fixing the mass of hydrogen over here. I think this is not visible to you, right? Because I am coming over this. So let's understand this thing over here. Okay. See, this law is stating that if two elements can combine to form more than one compound, we have two elements, that is hydrogen and oxygen. These are combining to form two or more compounds. Let's suppose we have this, we have water, we have hydrogen peroxide. They are forming two different compounds. Okay, so let us balance this thing. Let us balance these two equations. So we will be having 2 here, we will be having 2 here, and this is already balanced. Okay, let's calculate the mass of different species used in this reaction. Our hydrogen, we have 2 into 2, that is making 4, and for one hydrogen atom the mass will be 1 gram, so we have 4 grams. Oxygen, one atom of oxygen has 16 gram and we have 2 oxygen atoms, so it will be 32 grams. Similarly, for the water, we will calculate as 2 multiplied by mass of one water molecule, that is having 2H, 2 hydrogen atom, so 2 into 1 plus 1 oxygen atom, that is having the mass of 16, that is making nothing but 36 grams. Okay, so we have 32, we have 36, we have 4 grams. So what I am doing, I am dividing whole thing that by 2. So what I will get? 2 grams, 16 grams, and here I will be getting 18 gram. Okay. Now do the same thing for this hydrogen peroxide. We have 2 grams of hydrogen over here. We have 32 grams of oxygen here, and we have 34 grams of H2O2 over here. If you don't know how this 34 comes, then simply calculate the molecular weight of this thing. How will you get the molecular weight? You just have to mass the you just have to add the mass of different atoms, okay, and multiply the mass with the number of atoms. We have 2 atoms of hydrogen, so 2 multiplied by mass of 1 hydrogen atom, that will be 1, plus 2 multiplied by oxygen atom mass, that will be 16. That's nothing but makes 34. Okay. Now see guys. Hi Pashwa. Okay. See guys, for this, notice one thing. We have fixed the mass of hydrogen. For both the reaction, we have fixed the mass of hydrogen because the mass is of hydrogen is same for both the reaction. So we have fixed the mass. What I am changing? I am changing only the mass of oxygen. Okay. And the mass of oxygen that is combining with this hydrogen are in the simplest ratio. I can take the ratio of 16:32 and I will get 1:2. Now this is nothing but the simplest ratio. So I can say if I fix the mass of one atom or one element, okay, then other element are react in the ratio of small whole numbers. Okay. This is what the law of multiple proportion is. Now you have a question guys. Please solve and check out that this data is following the law of multiple proportion or not. Okay. Check out guys that this data is following the law of conservation of mass or not. Do the answer guys. Okay. I think you have made some calculations in your mind that we will go like this, Okay, let me make things simpler for you. I'm solving this question for you. Okay. You have 2 compounds, each containing only tin and oxygen. Okay, let's suppose you have 2 compounds A and B, both having only tin and oxygen, and no element is present. Okay. Now you have already given the percentage of mass of tin and percentage mass of oxygen in A compound as well as in B compound. You are provided with the percentage of tin and percentage of oxygen for both the compounds. Now you have to check law of multiple proportion. How will you approach this thing? See guys, first check that is the percentage is fixed for any element, let's say tin or oxygen in both of the compound. No, because here it is 78.77, here it is 88.12. Similarly, oxygen is also varying because here it is 21.23, here it is 11.88. Now for finding out whether the law of multiple proportion is valid or not, I have to fix the percentage of any element. Let's suppose tin or oxygen. Any element you can fix the percentage. How will you fix? You have to do some calculations guys. So let's suppose I am doing with for the compound A. What can I say? 78.77 tin, for 78.7% tin, we are having with 21.23% oxygen. I am replacing this percentage with the gram, because if I have let's suppose if I have 100 gram of compound A, then it will be containing 78.77 grams of tin and 21.23 grams of oxygen. So I am replacing this percentage with the grams. So for A, we have 78.77 grams of tin. For 78.7 gram of tin, we are having 21.23 grams of oxygen. Now what I am doing, yeah, so guys, what I am doing actually, I'm checking out, or I'm fixing the amount of oxygen here. I am, let's suppose, fixing the amount 1 gram 1 gram over here. So 1 gram of oxygen will be having 78.77 divided by 21.23 grams of tin. Okay, this is for the A. Similarly, we can calculate for B. We have 11.88 and 88.12. 18.12 gram of tin, and how much it is? 11.88. So for 11.88 grams of oxygen, we have 88.12 grams of tin. Now I want to fix the mass of oxygen to 1 gram. So for 1 gram of oxygen, we will be having 88.12 divided by 11.88 grams of tin. Now find out the value of this and this. Find out the value, guys. You will be having this value as 3.7 grams. You will get the value as 3.7 over here, and here you will get the value 88.12 divided by 11.88 will be equals to 7.4 grams. Okay. Now we have fixed the mass of one element. Okay, we have fixed the mass of one element, and we are calculating the mass of another element. Now what I have to take, I have to take the ratio. I have to take the ratio of 3:7 and 3.7 and 7.4. Let's take the ratio 3.7 divided by 7.4, and that's nothing but 1/2. This is the simplest ratio, guys. So what can I say? That tin is actually combining with in the simplest ratio with the oxygen to form different compounds. Okay, yeah. So you are understanding everything, guys? Understood? This is how you can calculate whether your law of multiple proportion is valid or not. Similarly, I'm giving you this question for the homework, guys. I'm giving you this question for the homework. You can take the screenshot, you can solve this question, and I will be solving this question in the next class. I will tell you what will be the answer and how it will be solved. Okay. Next, law of reciprocal proportion. This is quite complex as compared to law of definite proportion, as compared to the law of multiple proportion. This is quite complex. This is given by Richter. The name is actually not very important for you if you are preparing for the JEE exam. Okay, what this state, it states that when two elements combine, see, this statement will like this statement you will not understand if I do not explain with you with an example. But let's read this statement first. When two elements combine separately with a definite mass of the third element, two elements with a third element, so we have total 3 elements. We have 3 elements total over here. Okay. Then the ratio of the mass in which they do so is either the same or small whole number multiple of the ratio in which they combine with each other. Have you understood this thing? Have you understood this statement? I think no. You will not be able to understand this thing with the statement. So let's do with an example. Let's do with an example, so that you can understand this statement very easily. Chaliye. Okay, guys, so let's understand this thing. Okay, so let's suppose you have 2 elements. Okay, you have hydrogen, you have oxygen. Okay, you have let's suppose sulfur, you have oxygen over here. Okay, now these two elements are actually combined with the third element. Okay, with the third element, what will it form? It form H2O. And what will it form? It form SO2. Okay, this is quite simple. Now let's balance this equations. Let's balance this equation. You will get 2 over here and you will get 2 over here. Okay, and now this reaction is already balanced. Now you need not to balance this equation. Okay, now here we are having two different element combining with the same element, or combining with the third element. Okay, that is not matching with hydrogen and oxygen. We can also do this reaction with the hydrogen and sulfur. When hydrogen and sulfur combine, they will combine and form the H2S. That is quite simple. Okay, so any element can combine with the other one and form a compound. H2 can combine with the oxygen, or H2 can combine with the sulfur. So it can combine with each and every element. Now let's take the ratio of their mass. How will we take the ratio? First, go just like the law of multiple proportion. Just like law of multiple proportion. Okay, okay, we have 4 gram of what of hydrogen over here, and we have 32 grams of oxygen over here. We can calculate as 16 multiplied by 2, that will give you 32 grams. Okay, so we have 32 grams. Similarly, we have 36 grams of water over here. Similarly, you can calculate the mass of each species in this reaction. What you are saying, Siddharth? Okay, I'm not getting why you are saying no. Sulfur has a mass of 32 grams. Oxygen is having the mass of 32 grams. And here also you are getting 32 plus 16 multiplied by 2. That give you 64 grams. Okay. Now in both the reaction, in first reaction and second reaction, you have one species that is same, that is oxygen. Now let's suppose we have fixed the mass of oxygen over here. We have fixed the mass of oxygen over here, that is 32 grams. Okay, and that is already fixed, so we don't have to worry about this thing. We will have to worry only about the hydrogen and sulfur. Now we can calculate the ratio of hydrogen and sulfur in which they are combining. So we can calculate 4 divided by 32, that will give you 1:8 ratio. Okay, I got it. And that I told you that without an example you will not understand the definition of law of reciprocal proportion, because that's quite complex. So it's very difficult to understand by the statement. Okay, so that's why I'm giving you an example so that you can easily understand. So we have a ratio. We have a ratio of hydrogen and oxygen. Okay, we have fixed the mass of oxygen over here. We have fixed the mass 32, and we are calculating the mass of hydrogen and sulfur. Okay, so that is coming out to be 1:8. Now let us calculate this ratio when these two combine, this hydrogen and oxygen, this hydrogen and sulfur combine with each other to form the H2S. Now the mass of hydrogen here is 2 grams, sulfur mass is 32 grams, and here it is 34 grams. Okay, now calculate the ratio of this. Guys, if you calculate the ratio of this, then you will get 2 divided by 32, and that's nothing but comes out to be 1:16. What you can write that this 1:8 and 1:16 will come out if you multiply, like if you multiply 1 by 2 with 1 by 8, then you will be getting 1:16, right? 1:16. Okay, this is what this law of reciprocal states, that whenever you combine two elements with a third element of the fixed mass, then the ratio whatever you are getting is just the, is just same the ratio when these two elements combine with each other. Okay, or it will be the simply multiple of this. This is multiple of this and you will getting 1:16. So this was quite simple. Or you can also write this as not like this 1:2. You can write this as 1 minute 1:16 multiplied by 2 will give you 1:8, right? So this is nothing but simply the multiple of this ratio. Okay, this is what the law of reciprocal is, states. Now read the statement, guys. Now read this statement. You will understand everything. When two elements combine separately with definite mass of third element. Similarly, in which we have written H2 plus O2 giving you 2H2, right? We have written H2, sorry, sulfur plus O2 giving you SO2. We have fixed the mass of third element. So with definite mass, definite means fixed mass of third element, then the ratio of their masses in which they do so, the ratio of the masses in which they do so, here we were actually getting 1:8, okay, is same or some whole number multiple of the ratio in which they combine with each other. So when they combine, like when the hydrogen and sulfur is combining with each other, we are getting the ratio 1:16, right? And this is nothing, 1:8 is nothing but simply the multiple, the whole number multiple of this ratio, right? Now you understand what I have written over here. Now you have understood. I think you have understood, guys. Okay, so I have written also the complete explanation also, so that you can in future you can also understand this thing. Good job. Okay, so this is a question, guys, where you have to check that law of reciprocal proportion is valid or not. Okay, for this question you have to select two compounds. Anything you can select. You can select NH3 H2O, you can select H2O N2O3, you can select NH3 N2O3, whatever you can select. I will select very simpler one, that is NH3 and H2O. This is simpler one, guys. So select the thing and combine and form, like write the reaction for this. Okay, so we have a NH3, we have nitrogen, we have hydrogen. So actually this compound need not to be like, just a second, I'm very thirsty right now, so my tongue is actually slipping. Okay, so here you don't have to write all the reaction, because the mass is already given to you in the percentage form. Like if you are having the 100 gram of NH3, then in this you will be having 82.35 gram of nitrogen, 17.65 gram of hydrogen. So you are already provided with the mass here, so you don't have to calculate the mass. You just do some calculations and find out that law of conservation, law of reciprocal proportion is valid or not. Okay, so for this what will I do? I will write NH3, I will write nitrogen, I will write hydrogen over here. Okay, so the nitrogen mass is 82.35 and hydrogen mass is 17.65. Okay, similarly for H2O I am writing over here mass of hydrogen and mass of oxygen. Oxygen is 88.9 and hydrogen is 11.1. Okay, now see guys, there is one element that is common, that is hydrogen. So what I need to do, I have to fix the mass of hydrogen only, but the mass is given different. Here it is 17.65, here it is 11.1. Now let's suppose I want to fix the mass of hydrogen. to 1. I want to fix the mass with the 1 gram. So for 17.65 gram, I have 82.35 grams of nitrogen. So for 1 gram, I will be having 82.35 divided by 17.65, right? Similarly, if I fix here the mass of hydrogen 1, then because I was having 11.1 for 11.1 gram of hydrogen, I was having 88.9 gram of oxygen. So if I'm having 1 gram, then I will be having 88.9 divided by 11.1 gram of oxygen, right? So what I have done, I have fixed the mass of hydrogen. So we have a mass of nitrogen over here, we have the mass of oxygen over here. We have calculated. Now let's take the ratio of this nitrogen and oxygen. So nitrogen and oxygen, I'm taking the ratio 82.35 divided by 17.65 and that's how it will give you 88.9 divided by 11.1. Calculate guys, what will it give you? The value it will give you. Calculate this value. Okay, I'm calculating in the phone because I don't know the answer, and if I calculate here I will take a lot of time because my calculation is not that fast as your. I'm a chemistry teacher, not a math teacher. Remember that, yeah. Remember that. 82.35 divided by 17.65 and that comes out to be 4.66. Here I am getting 88.9 divided by 11.1. that comes out to be 8.00 ऐसे आ रहा है, मतलब this answer is coming actually. So 4.66 divided by 8.00, that is 0.5825. This is what I am getting. Maybe your answer may be different from me. It may happen. Now I have calculated the ratio when these two compound is formed. Okay, now I will calculate the ratio in this, in N2O3, when both nitrogen and oxygen combine with each other to form N2O3. Okay, so here you will get the percentage as nitrogen and oxygen. We will divide 36.85 with 63.15. Okay, so we have 36.85 divided by 63.15. Now solve this question guys. Solve this question. What will you get over here? You are actually getting 0.5835. Then that's actually comes out to be almost equal. Like I can write this as 0.58, I can write this as 0.58. Now you can actually tell that ratio is coming out to be same. These two values are same now, because these two values are same, so I can say that ratio are same. So I can say that law of reciprocal proportion is valid over here, because that's what my statement was saying. The ratio is same or it is the simple whole number multiple. So it is coming out to be same, though our law will be valid. Now let's talk about the next law, that is the Gay-Lussac law of volume. Okay. Oh, you are getting 1. No, we will not getting 1. You will get this value. Check. please do calculation again, because I have calculated in the calculator. Okay, let's talk about the next law, that is the Gay-Lussac law of gaseous volume. This is given by the Gay-Lussac. Obviously, Gay-Lussac has given this law in 1808. 1808, he has given this law. What this law states, it states that when gases combine or produced in a chemical reaction, whenever the gases is combined or produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. What this means, guys, this means that, let's suppose, if I am taking hydrogen and oxygen in the gaseous form, and I am forming the water also in the gaseous form, okay, then what will happen? See, okay, let's do this over here. We have hydrogen, we have oxygen, we are forming water vapor over here, so all are in gaseous form. Okay, let's balance this reaction. We have 2 over here, we have 2 over here. Okay, so what I can write, if I have carrying out this, if I'm carrying out this reaction at the same temperature and pressure, or you can write at a fixed temperature and pressure, then 2 volume of hydrogen will combine with 1 volume of oxygen to form 2 volume of H2O. What this means, you can replace this volume with the unit of volume. For example, if there is 2 liter of H2, then there will be 1 liter of oxygen and there will be 2 liter of water vapor forming. Similarly, if you have 20 liter over here, then you will be having 10 liter and you will be having 20 liter over here. You just have to take the take this stoichiometric coefficient in the consideration. So everything will should be in the ratio of 2:1:2. You can calculate this ratio. You can calculate the ratio for this thing. You will get 2:1:2. Similarly, if you are taking 100 liter over here, then similarly it will be 50 liter, it will be 100 liter. Okay. So they are in the simplest ratio. They whatever the volume is combining or forming, they are in the simplest ratio. Like if you are calculating the ratio of the volume of hydrogen and oxygen, then that will be 100 by 50, and that will be 2:1. So this is the simplest ratio. This is the simplest ratio. Okay. Oh, you are saying ratio is 1, but my ratio was actually coming 0.5825. Calculate, guys, calculate, because the ratio will. Okay, you are actually doing what. Oh, I know what you are getting. You are actually dividing this 0.58 with this 0.58. That you don't have to do, guys, because you just need to like check out that these ratio are same or not. These ratio are same or not, or is this is a multiple of this thing or not, because we have calculated this ratio for N2O3 and we have calculated this ratio for NH3 and water. Okay, so we are getting this value for this NH3 and H2O, and we are getting this value for N2O3. Now you have to check that whether these ratio are same or not, or this ratio is simply the whole number multiple of this ratio or not, okay. Now these ratios, these ratio both are same, so that's why the law of reciprocal is followed. Okay, getting my point? So you don't have to do this 0.58 divided by 0.58. That will be wrong. Okay, so I've explained the Gay-Lussac law in detail. This is what your this is what your book is doing actually. It is taking hydrogen, it is taking oxygen, it is forming water vapor, and it is also saying you that whenever the hydrogen and oxygen combine with each other, they will combine in a simplest ratio. 100 by 50 will come as 2:1. Okay. So this is nothing but a simplest ratio. So they are combining in the simplest ratio. Okay. So next is Avogadro's law. Avogadro's law, we will be doing only the statement, guys, because this we will do in detail when we will understand about the mole. What is mole? What is the atomic mass? What is the molecular mass? We will study in detail. But I have talked about the atomic mass and molecular weight in this lecture because I can get an idea that what is atomic mass, what is molecular mass from your previous classes, because you have studied in class 9th and class 10th about molecular mass and atomic mass. Okay, so that's why I have talked or I have explained something in the terms of molecular mass and atomic mass in this lecture. But yes, I will also teach you in detail what are atomic mass, what are molecular mass. I will teach you in detail. Okay, now let's talk about the Avogadro's law. Yeah, Avogadro actually given his hypothesis in 1811. Okay, what his hypothesis states? It states that equal volume of all gases at the same temperature and pressure should contain equal number of molecules. Now ignore this, guys, because this actually I have simply copied from here to here, so this is not included. Please ignore this thing, guys. Please ignore this thing. Okay, so what we can understood this thing, for example, let's suppose we have two gases, we have hydrogen and oxygen at same temperature and pressure. Let's suppose temperature is fixed and pressure is fixed. Or you can say, if I'm taking hydrogen at temperature, let's suppose 300 Kelvin, I'm taking oxygen at temperature, let's suppose 300 Kelvin. Okay, similarly, if let's suppose I'm taking hydrogen at pressure, let's suppose 1 atmosphere, and oxygen at pressure 1 atmosphere. So for both the gases, the conditions are same. Temperature and pressure are same. So if the volume of H2 is same as volume of oxygen, if the volume of H2 is same as volume of oxygen, then what I can say that number of molecules of oxygen will of hydrogen will also be same as number of molecules of oxygen. Okay, so if you have same temperature, same pressure, and even same volume, if you have all the things same, then number of molecule will also remain same, guys. This is what a Avogadro hypothesis is. Okay, so we have finished with the laws of chemical bonding, and I have given you some homework, guys. Please do this thing. Please do the homework, guys, because in the next class, if you don't do that homework, then you will not be able to understand, or you will not be able to do the questions related to this mole concept. Okay, so let's do the exercise question. This is given in your exercise, NCERT exercise. You have given the mass of dinitrogen, you have given the mass of dioxygen. Okay, different mass of dinitrogen, different mass of dioxygen. It is asking you which law of chemical combination is obeyed in the above experimental data. कौन सा जो लॉ है केमिकल कॉम्बिनेशन का वो यहाँ पर फॉलो हो रहा है, ये आपको बताना है. Sorry, I should talk in English. Yeah, my mistake. It is actually asking you which law is actually following here. Okay, now see, there is a trick over here. What is the trick? If the mass of something is fixed, let's suppose nitrogen is fixed, and the mass of the other element, that is oxygen over here, is changing. then I can say that law of multiple proportion is valid over here. Okay, but if let's suppose the case was like the mass of dinitrogen is fixed and the mass of dioxygen for that is also fixed, then I will say law of definite proportion will be valid here. Okay, but this is not the case. Mass of nitrogen is fixed but the mass of oxygen is changing, so that's why the law of multiple proportion will be valid. Okay, next come to the 1.26 question of NCERT. Okay, question number 1.26. What it is saying, you have 10 volume of dihydrogen gas react with 5 volume of dioxygen gas. You have 10 volume of dihydrogen gas reacting with the 5 volume of oxygen gas. How many volume of water will be formed? How many volume of water will be formed? It is asking you this thing. Now first balance this equation, guys. Balance this equation. You will get this 2 and this is 2. So we can say hydrogen and water. The ratio for hydrogen and water is 2:2, that is 1/1. So whatever the volume of hydrogen over here, the same will be the volume of the water. So the water will have the volume of 10. Okay, so the answer will be 10. So guys, I hope you have understood everything. Thank you so much guys, and bye bye. I will meet you in the next class, that will be day after tomorrow. Okay, so bye bye, and if you have any doubt you can message me on my profile. That for that the link is given in the description. You can like, share and subscribe. You can like to support me so that I will become motivated guys, and in the next class I will do lots of hard work for you. And yeah, and also if you are thinking about taking the subscription, you can use my code, that is KJN code, for getting 10% discount. So bye bye guys, will see you later in the next class. Bye bye, please do the homework.